დავიწყოთ? კაი, ქართულად გვინდა თუ ინგლისურად? თუ ეს ჰა? რას უნდა დავაჭირო? Well, since we have an English-speaking person, let's respect English-speaking people. Also considering that I don't really know much of the terminology in Georgian. Okay, so we'll be talking today about, I will start initially by talk generally about operational research and what it is about, optimization solvers and interfaces, basically how to use optimization, how to do optimization in general. And then I'll just bring an example of data envelopment analysis. Don't judge me too much because it's a method that I got excited relatively recently. So I have done some stuff some years ago, but now I got re-excited about it. So I'll be, yeah, basically don't judge me too harsh. I guess most of you guys are from data science and I don't know, machine learning, AI, that kind of stuff. I don't know much about it, but operational research algorithms are often used in most of those applications. So it's more or less a basis for many of the things that is done next in all the spheres of applied mathematics or computer science. So basically, operational research is a branch of applied mathematics. It aims to solve a decision-making problem. Basically, the idea of operational research as a separate field is that it works with the design of the problems, solutions, and also finding a method for solution, defining the solution method. So our main directions or main tools are optimization. We might do process simulation, do statistics for getting parameters, primarily for optimization. There are methods of decision analysis and game theory. So most of the logistical problems, corporate problems like companies' revenue management, inventory management, portfolio optimization in the financial markets, in most of the engineering problems in energy industry, for example, airport management and airport planning. Well, if the Microsoft does not make something bad, the rest of the algorithms from operational research, they normally work if they are deployed. Even farm planning, defense industry. So basically the initial idea of operational research is that it came from during the Second World War. It became a field during the Second World War in UK when they actually had a specific mathematical problems to solve to basically save UK during the Battle of Britain. The initial algorithms were about deploying the radar systems around the country in order to have a quick response. And initial optimization models were about that. Defense and military industry very actively uses operational research. It is also used in machine learning and AI applications. The idea is that the reason it is used is because many of the models that you are using or the packages that you are using, the underlying algorithms or underlying solution algorithms would be coming from applied mathematics, which is from the branch of operational research. So what we do is we basically identify a problem, start putting together the building blocks of the problem, we formulate it, we define the constraint sets, objective functions, and then try to solve it. or if it's too hard, we are trying to figure out an algorithm to solve it, or either to optimality, or in many cases, optimality is not possible. So we are designing a problem to improve solution as much as we can. Most standard problems are in the modern times are solved in well-developed optimization solvers. These would be linear programming, infinite linear programming, or quadratic programming problems. They are well solved in optimization solvers. The standard way to solve most of this, all of these problems, would be to deploy to use a simplex method or an interior point method, and then what you basically do is and if you have some integer solutions, you might do a relaxation and then first use a simplex method and then try to find a much better solution, search around the tree of solutions. So, most of these well-developed solvers, most of them have an extremely good algorithm. Don't try to solve it like to create a solution algorithm for linear programming problem yourself or stuff like that, because it's already done and you're not going to improve it anyways. So what we normally, when we are trying to put together a mathematical programming problem and trying to solve it, what we do is we have several steps. Basically, the first is we formulate a problem mathematically, basically write it on a piece of paper or put it down on latex, and then what we do is we code it in an interface. Normally, most of the optimization problems cannot be right away coded in Python. You have to use a certain kind of a package or an interface package in order to program it as an optimization problem. And then you are finding a data, getting an input parameters, and putting it together, and then send it to the solver to get a solution. So you first use mathematical language, then you are choosing your preferred interface language, and then identify a data or input method to the parameters, to the parameter inputs. So what you often have with an interface, in different interfaces use different kind of inputs. For example, one of the more popular optimization interfaces uses dictionaries, for example, which is not very convenient because dictionaries are terrible in general, in my opinion. Some of the more modern interfaces, they use data frames right away, or they might use NumPy arrays from Python. So, and then you deploy a model to the solver, of course. Now, how do we choose a right type of solver? So, in order to get a decision about the solver, you have to consider a few things. So first is what type of problem are you dealing with? So for different types of problems, we have a different kind of solvers. That is primarily relevant for if you're doing something non-linear or something conic or optimization problems. All solvers don't solve those kind of problems. All solvers don't solve non-linear problems. Most of the solvers, though, solve linear problems, or mixed integer problems, or quadratic problems. Okay, if an optimization is convex, first solvers are developed around solving convex problems, and then they are developed around solving something more complicated, which is a non-linear problem. Of course, when things get more and more advanced, solver might not be designed around your problem formulation, so you might have to use a solver and then redesign an algorithm in order to get a improve your solution and partly develop your own solution method. Second thing that we look at when we are trying to solve an optimization problem is a solution time. For solution time, I mean, for many applications it doesn't really matter. I mean, if you're doing a scheduling for a university classes, right? I mean, if it's solved in 3 hours or 4 hours or 10 hours, why does it matter? You're solving it in the beginning of the semester and then all your schedule is done, right? So you might not care. But if you are solving for example, a power system distribution problem, solution time is the main thing that you will be looking at, because power system has to be optimized every minute, every second, or every 15 minutes very often. And in that case, you will have a very large problem, and that very large problem has to be solved extremely quickly so that you deploy the results as soon as possible. And the last thing is quality of solutions. For those of you who might not have dealt with optimization before, most of the problems have there is a primal problem, which could be a maximization or minimization, and then there is a dual problem, and the dual problem is basically the other way around. So if you have a maximization problem, you have a redesign of the problem to make it a minimization problem, or the other way around, and that's your dual problem. Solvers most often solve both. They take a primal, they solve both primal and dual problems, and if you are dealing, for example, a mixed integer linear program, which might not have an exact global optimal solution, it will give you a difference between a gap between primal and dual results. And as the smaller is the gap, the better your solution is, basically. Theoretically, primal and dual problems should give you same results. So, depending on the scale and complexity of your problem, you might be using a commercial solver or an open source solver. Many of the open source solvers are now becoming so good that even some commercial packages are using those as well. And I will give that example soon. So, for commercial solvers, there are several very good linear and quadratic solvers. Gurobi is considered to be the fastest solver for mixed integer linear programs and linear problem and quadratic problems. There's a relatively older solver that used to be an extremely popular, not that popular anymore, but used to be very popular, IBM Cplex. So if you get interested in optimization, you might find in a lot of places that something was solved with Cplex, and the Cplex is a very well-known solver. FICO, it's a credit scoring company. They have their own optimization solver, and that solver actually comes with its own interface and its own interface language. It's called Mosel. And for optimization problems, it is actually very intuitive interface and nice. So again, many companies are using FICO Xpress for many different kind of applications. There's a cardinal optimizer, COPT, that is good for very large scale problems. There's Mosaic, which is extremely good for conic and semi-definite programming problems. There are non-linear solvers, Artemis Knitro, for example. My company actually has some relations with Artemis Knitro for energy kind of energy. For the energy industry, it is very well used, especially if you are designing a non-linear problem in the energy industry, which is most of the physical processes and engineering problems in the power systems are non-linear, and Artemis Knitro is actually developing its solver around that idea. and especially for energy industry. So ConOpt and GAMS actually, that's you probably know a GAMS environment. It's a pretty famous modeling language and a tool. They have their own nonlinear solver. You can program it within the GAMS environment. There's also Baron, which is a global optimization solver for non-convex problems. So it's a complicated one. In most cases, you will try not to deal with it because, yeah, I mean, if you can simplify, try. I mean, you should do that for most of the optimization problems. I mean, one of the most fascinating things about optimization in general, in my opinion, is how little we can solve actually to an exact solution. Most of the problems are not solved with a perfect optimality, right? So, I mean, most of the physical problems in real life, they are often not solved to the global optimality. So, yeah. And there is this saying that I heard recently, which says KISS, meaning keep it simple, stupid. So simplify it if you can. For the open source solvers, very good, relatively recent one. It was developed like 3-4 years ago. It's HICE. HICE actually stands for whole, and I don't remember the other names, but the first one is whole. So it's a mixed integer linear problem for convex and quadratic problems. And the most fascinating part is that HICE, an open source solver, is now integrated in MATLAB, and MATLAB is actually using the HICE for its linear problems. It's like it got rid of its own solver. A SciPy library in Python also uses HICE now for simple linear optimization problems. A famous old and standard one is GLPK for linear problems and mixed integer problems. That's one you might often meet as well in many applications. And there's this open source operational research algorithm initiative called CoinOR, and they also have several solvers. That's CBC, IPOPT solvers. There's a global optimizer, the Queen, and there's also this BONMIN, which is also within the developed within the CoinOR. It's basically an open source code in C++ that you can use for mixed integer non-linear problems, which is a complicated one. But the good thing is that the code is open source, so you can play with it if you want. Solver interfaces. I think that for most of the cases, if for the, I don't know, data science applications, for example, you might not have to deal with the solution method, etc. You might just want to know a solver and know an interface. For interfaces, most of the commercial solvers now, they have their own interface developed in basically an interface package, which is developed in Python, C++, Java, .NET, MATLAB, R, and there's also a famous language, Julia, which is very good for optimization. But most of them have it in Python, so if you know Python, you can use most of the solvers. As I said, FICO Xpress and IBM Simplex and GAMS, they have their own interface, but most of them are also now developing a Python version. So, for example, there's a GAMSPy package, which you can use instead of the GAMS interface if you don't want to use it or buy it or basically learn GAMS separately as a language. There's also an open source interface package. It's called Pyomo. That's the one I normally use. You can call for many different solvers from Pyomo. Basically, you can just For simple problems that you can see as a matrix or a vector or something, I mean, as matrices and vectors, you can use, so if you are stating like a generic problem, not designing a separate constraints separately, you can use linear optimization package from SciPy. So SciPy has its own linear optimization and it's using the Heiss optimization. There's a commercial interface package, Ample, which you can learn in order to use all different optimization solvers actually. So the main choice is between two things. So one is, do I learn all the separate Python packages for every solver that I want to use, which means that if I want to use Gurobi, I have to learn Gurobify, how it works. If I want to use Heiss, for example, I have to learn Heissfy, and how to use it. Ample solves that problem. So with Ample, you can learn just Ample, and then call for a solver from the Ample. Okay, so that's a good thing about it. So it's basically an interface package that solves your problem of learning many different packages in for different solvers, and just use one interface and one approach. There are also some tiny differences between different interfaces. One is how intuitive it is. For example, FICO Xpress is very intuitive. You pretty much write it as you write a mathematical programming. I mean, as you would write an optimization problem on a paper. Okay, the idea is very close to it. Pyomo is also very intuitive in that same way. So you basically define, and I will show it to you in the next slide. You basically define sets, you define objectives, parameters, decision variables, constraints, constraints, and basically goes through that process as you would build a model on a piece of paper. Some other packages have some a bit more tricky moments that are good for. I mean, they're not as intuitive in writing, but they might have some other features that might be useful. For example, some of the capabilities of interface could be creating a subindex. So if you have a set for let's say a decision variable, right? And that set has its own subset, right? So in that case, in some of the optimization interfaces, like Ample, for example, you can define a subset as well. Okay, so I don't have a whiteboard to write it, but okay, so you basically have you basically when solving a problem, you might loop over a set and a subset in parallel. Okay, so that's what it allows you. In some other interfaces, it gets more complicated to do it. Okay, especially if you have the set and subset sizes are very different. It might be complicated to loop over them. How do we operate these interfaces in general? In general, most of the interfaces have an option to either define an abstract model, which is what you would know as a general optimization problem, right? So maximize it or minimize an objective with certain with the multiplication of two vectors, and then with a and with a constraint which would be something like AEX is less or equal than B, right? So it's like generic way is an abstract problem. So you have to redesign all your matrices and all your data in order to fit that abstract model, and it will solve. Okay. And then you have to also think about like what did you mean in the transformation of your matrix? What did you mean in each transformation of your matrix so to fit one standard way? Okay. With a concrete model, you can basically define your problem as you would write the full problem in your paper, so a specific problem, right? With all the specific different constraints. So in this case, you are adding every constraint to your problem as you code the concrete model. So you would define a set, then you would define parameters, decision variables, then you would define all the functions, which is objective function, constraints. The way it works normally is that you define an objective function, you define a constraint environment, and add constraints to it. And within the modeling environment, okay? And then you deploy a model to a solver and try to store outputs, decision variables from the model. So to get more concrete about that, in Pyoma, for example, in order to define a model, you create this model environment, let's say concrete model, okay? Then you define, you basically create a variable called model, where you store a concrete model. Then you create sets, for example, I don't know, time sets which range from 1 to 12, something like that. Then you define parameters, it's a param, and you define a set that this parameter should, within which this parameter operates, and you initialize data to those parameters. So where should it get the data? In Pyoma, you normally operate with dictionaries, so you will have to have this, if your parameter is db, you are defining, you have a dictionary for this parameter, and then you're adding this to your parameter part in your model. Then you decide to define decision variables, which also have this different kind. You can specify different kind of sets, 3 different sets, and actually in different interfaces it happens in a different way. In some interfaces you might constraints about specific decision variables, which is, for example, it should be greater than 0, or should be is 3, or if it has to be any real number, or an integer, or a binary number. In that case, you would, in some interfaces, you might define that as a separate constraint. In Pyoma, you do it while defining the variable itself. So you are specifying that the domain of this variable is positive reals. For those of you who are dealing a lot with statistics, I forgot to specify that. Normally in regressions, we call variables and parameters different things. So in statistics, they call parameters what in optimization people call a variable in reality. Because in statistics, you get an estimate or a parameter, right, for beta, right? But in optimization, what you are, your decision variable is actually z beta. So you are trying to find its correct or optimal value. So that's a bit different thing between statistics and operational research terminology. So yeah, I mean, if you are defining the objectives, then you might have something like this. In Python, you would have an objective expression where you specify a formulation for objective. You are normally looping with for loops in most of these cases. Then with constraints, what you're doing is that you're creating a constraint list, which is for different kind of constraints, you can create different constraint list. And you are saying, okay, there is a constraint list that I'm defining, and then you're saying you are creating some kind of a mathematical formulation. For example, in this case, f means less or equal than whatever this parameter is. whatever the decision variable is, and you are adding it to a constraint list. Okay. Then if you have to define a different constraint, you might create another loop and add constraints to those. You can also define constraints within the functions. So, for example, you might define a function that yields some kind of that should return some kind of an equality or inequality for you, and then you are adding to a constraint that specific function or rule, as they say here. So in the end, what you are doing and this one is a bit small, so it's hard to see. Okay. Here we have how we solve it in the end. I don't know if it's visible, but yeah. So what you are then referring to is Pyomo has a solver factory. You're saying solver factory, specify a solver, and then you tell it that solve this thing called model. You can call, I mean, instead of naming your thing a model here, you can name it, I don't know, Murtaz, and it will solve you a Murtaz. Okay? Yeah, and then you are, I mean, you might specify different kind of outputs that you might want to get, for example, timing of solution. And then you write down the results. If you have any questions, actually, before going to the next topic, I would probably get the questions now about the solvers and optimization in general, and then I will go for a specific case.
Yes, I wanted to know the pricing model of this commercial software. Do you pay on what pay do you pay?
You are paying normally per user, per machine. There are cases when you might pay per subscription as well, if you are working on the cloud. Many of the solvers, Gurobi for example, now has a cloud as well. So you might pay for a subscription to a cloud. Actually, for most of the solvers now, they don't make money with subscriptions or usage. Many of them just give you a free usage. The way they make money is by helping you to solve the problem in a way that if you are solving something non-standard, then they are providing a consulting service to help you design a solution method using their solver. Okay, so sort of a both consulting business and then solver at the software business. Okay, yeah, and so solvers. I asked a quote like 3 years ago, and I think that it was around, for user, it was around $10,000 per year for 3-year subscription. Yeah. So again, if you are using, if you are not modeling something extremely complicated extremely complicated linear or mixed integer linear programs, like use open source, Heights, for example. It's good enough for like simple problems. I mean, problems that I'm going to present today don't use like commercial solver for that. Although in many cases for education or NGOs and stuff, they actually also provide it for free. For commercial ones, they might give you, I mean, it depends on negotiation, might give you a very good quote for the price, I mean, very low quote, or give you a solver for free, and then if you are using it for some commercial purpose, you might then you might pay, okay? Or if you are implementing at some company, yeah. And normally the way they write those solvers is such that you cannot really crack it, like some people do with Microsoft, especially different Georgian ministries. Yeah. Yes, please.
Yeah, I have several questions, but
Yeah.
about basics. What means it's linear and non-linear on those solvers? It depends by relationship in parameter or in data.
Yeah. So linear linear solver means that it solves a linear problem.
Okay.
Linear problem meaning that objective and all your constraints are linear in an optimization problem.
Could you please give me an example of linear problem and non-linear problem?
The next one is a linear problem, so I will show you the linear problem right away, okay? I mean, since I don't have a whiteboard, it's hard for me to really show it to you, but yeah, I mean, next problem is linear problem, so you will see what the linear problem is. Non-linear problem is that, like, for example, either in constraints or in objectives, you have a, I don't know, a cubic term or a quadratic term. Okay, quadratic. If you have a quadratic term in objectives and in constraints, you have a quadratic problem. Okay. The objective is something that you are trying to minimize or maximize, and are constraints that the minimization or maximization problem has to comply with.
Can I ask several questions?
Yeah.
I'm new in this topic, so I'm interested in. So when business want to solve some problem, what problem they describe to you? So, for example, it's for selling or for shopping or retailing.
Okay, to keep more relevant to today's next discussion is, I mean, the question would be, let's say I have 10 branches of my shop. I mean, how do I decide which one is the most efficient, for example? And then I create an optimization problem that helps me to decide which will tell me which one is the most efficient one. Or, for example, okay, I have this kind of limitations and tell me how much product should I make in order to maximize my profits.
So run all of this code, what do you get? What result, what output of this?
I mean, in this case, my output might be, let's say, how much of a product do I produce? I mean, I don't know. Let's say I'm producing a lemonade, a Pepsi, or cola, and water. Okay, there's a company that does that in Georgia. But the question is, okay, how much of which product do I produce to maximize my profit? I can build an optimization model for them, and the output would be, okay, produce, I don't know, 10 million bottles of cola, 5 million bottles of lemonade, and 15 million bottles of water.
So when we put some dictionary in input, we get some dictionary in output?
You can get in output you might get even a Panda data frame. Depends on the interface that you're using. Any other? Okay, then let's talk about the data envelopment analysis. So, data envelopment analysis is a technique based on linear programming that basically compares performance of a set of units based on certain inputs and outputs of that unit. So, in econometric or statistical approach with a regression, you will probably need to find some ideal functional relationship between inputs and outputs and find, okay, if I have a certain functional relationship, I get this estimate, and then the estimate tells me I increase this parameter or this variable by 10, and my output will be, I don't know, 20, for example, right? With DEA, we are avoiding these functional relations. We are saying that we are making the decision these units based on the best practice or most efficient unit. So we are, I mean, those of you who studied economics, maybe you know production possibility frontier or efficiency frontier. So what we are trying to do is we are to try to build an efficiency frontier and then map all the units compared to that efficiency frontier. So we might say, think about, let's say, a company has branches, shops, right? Carrefour or something like that. They have certain number of employees. They put in each shop certain amount of product, and then they get a profit from that, right? So the employees and product will be my inputs, and my output would be profit, right? So any organization, process, business, or units on which I'm running a DEA, it's called a decision-making unit. DEA algorithm could be two types, depending on what I am interested. I mean, depending on which direction of efficiency I'm interested in, whether I'm interested in input efficiency or output efficiency. That would be an input-oriented model or output-oriented model. So DEA algorithm looks like that. So what I have here is I'm trying to minimize an efficiency parameter, theta. Epsilon is just a small number, so that the rest of this objective function does not become too large. Okay, and then I have and I'm minimizing with slack variables. Let's forget about this for a minute. Just let's think about we are minimizing theta, which is an efficiency parameter. So what I'm doing here is we have an input parameter. We are multiplying each input parameter by lambda j, and lambda j is a distance, are the peers of each DMU j. It measures the proximity of DMU under investigation. So what it is a decision variable. So this is my data here, and lambda j is my decision variable as well as its slack. And what I'm trying here to do is to find lambdas and slack variables in order to ensure the equality with a certain unit. So this is a fixed unit. So this is for there is an input parameter for different inputs, but for one specific unit. Okay. So I'm trying to run this linear program comparing every unit to one specific unit. Okay. And then what we have here is basically we are trying to somehow weight every input for each input for all the units, so that I get a measure of theta and slack variables. Okay. I do the same with outputs, but since my model is input oriented, I'm trying to measure input efficiency. Okay, so I'm also trying to figure out such lambda which gives me a distance towards for each decision-making unit towards both inputs and outputs. Okay, so what these slack variables are doing for me is that if lambda j does not get a measure that exactly equals my input parameter, this slack variable helps me in order to tell me, okay, like this is the best lambda I could get, but you have to add additionally this much of an output, for example, or an input here, okay, or decrease your output by this. So in this case, it's lambda j, si minus, and plus slack variables. And theta is basically a free variable. It can get minus or plus. What I'm doing here in objective is that I'm trying to minimize it, meaning that I am trying to, for each, since this one is with minus, I'm trying to maximize the slacks for each and every unit, meaning that in order to minimize it, the theta should be as small as possible, and slack should be also as large as possible. Okay, meaning that as large as possible, and that will give me a theta that would be an efficiency parameter, which actually in the end would be between 0 and 1 always. So my efficient decision-making unit would be one which has theta is 1, and slack variables are 0. So that would be my best unit. And then I will get an information about, through lambda j's and slacks, about distance from this unit, this perfect unit, to every other, distance from every other decision-making unit to this perfect unit. Okay. Output-oriented model works pretty much the same way. It's just that I'm trying to maximize the output, of course, with this absolutely same philosophy. It's just that I will have this phi parameter here, which would be with outputs. Okay, so in this case, what I'm trying to do is I'm trying to maximize the phi, and in this case, my efficiency would be actually 1 over phi. And what it would give me is, again, distances towards peers, slacks that are also like an additional distance that I couldn't get with my optimal distance measures, and the phi that basically gives me an efficiency result. That measures my efficiency of my DMU. And my DMU, for my DMU again with an output-oriented model would be phi should be 1 and slack should be 0. Now if I solve this and consider that if I'm doing a data envelopment analysis, let's say for 30 decision-making units, and to do this efficiency mapping, I have to solve 30 linear programming problems. Why? Because I have this fixed guy here. These fixed guys here, right? So I am, by every linear programming problem, I'm trying to compare every other unit to this one unit, okay? And figure out whether that one is efficient or not. Now, with values theta will be between 0 and 1. With phi, its degree of inefficiency would be, how inefficient the output is for a DMU would be 1 over phi in this case. And basically, after running this, after getting the slacks and efficiency parameters, what I can do is the following. What would I do with regression? With regression, I would say, okay, this beta is, I don't know, plus 5. So every time I increase my variable, it gives me a 5 times more impact on, let's say, an output, right? The philosophy is a bit different here. It tells me for my inefficient decision-making unit, what I can do is I can calculate, if I change my current input parameter, what can I get for an output parameter? Okay? So what would be my my perfect output parameter? Sorry, the prediction of my output parameter based on these optimal slacks and optimal efficiency measures, okay, both for input and output. So what it tells me is how much can I increase, let's say, number of people at my shop in order to make my branch more efficient, okay, or to make it as efficient as another branch that has been modeled as the most efficient one. The same happens with an output-oriented model. Basically, they should give you more or less, they will give you similar result. Just what depends on your what is your goal. Okay, if your goal is maximizing profits, then it's better to run an output-oriented model, and if your goal is optimizing, having most efficient inputs in your shops, then you should run an input-oriented model. So initially, DEAs were modeled as a conic optimization problem. There's a cone over which we are optimizing. We are trying to get to this point here. And we are optimizing, so they were operated as a constant return to scale. So they were assuming a constant return to scale. So they were saying, okay, my decision-making unit itself is running optimally as it could run. Okay, so I have to change something seriously. So people, basically what this assumes is that people at my unit are not working bad, so they are not lazy. It's just that there's something going on, there's not enough of them or something like that. So it's like if I increase their number, my output will increase proportionally, right? So with the constant returns. Now, and then there was 10 years after, or 10 or 6 years after the CRS model was developed, there was a 1984, the variable return to scale model was created. And what it said is, okay, what if I add additional constraints to make sure that that my scale of that my return to scale is variable. So the way they did it, they added a convex hull, meaning that they sort of cut this plane here, the solution plane, and try to find an area which consists of optimal solutions, and then find the best solution among those optimal solutions. Meaning that which is done in a very simple way. You're just adding this as a constraint to the model before, as an additional constraint to the model before. So you just basically cut the plane and then search only around that plane. Okay? And that gives you an opportunity to make it as a variable return to scale. So you might have different directions of solutions, let's say so. So there's also a DA model, which in most of the literature you will actually find this kind of model and not the one that I presented before. And it's called a multiplier model. And the reason before that is because this gives you much, let's say, much clearer results. Okay, so you might not want to deal with all the slacks and peer distances, etc. You will just want to get a weight or efficiency of each input and each output. This one, I mean, for those of you who have been dealing with optimization before, this is basically a dual problem of the one before. Okay, so it's the other way around. What we are doing here is that we are taking a weight for that and trying to, for each of my parameters, I'm taking a UR, which would be, give it a weight, an optimal weight, so that I maximize my output, all my outputs, basically. Okay? And then I'm trying to make my, I'm assuming that there is some linear relationship between my inputs and outputs, so I'm trying to find the best weights for inputs so that I exactly match my outputs. Okay? Sorry, not fully exactly. It's like should be difference should be less than 0. And then I am also adding this one, which says that multiplication of all my efficiencies with my input should be 1 exactly. Okay, so my weights among input should be distributed so that I get 1. Okay? And then if I have this term here, this will be a variable return to scale model, meaning that I have an opportunity to get an additional decision variable that creates an opportunity to jump to different solutions, or which is an idea of variable return to scale. And then if I get the theta 0, I have a constant return to scale model. Okay. Well, let's talk about how do we actually use it in practice. So this is a relatively simple problem. Zura might be interested about that actually, because he does education research. So let's say we have an input which is cost per pupil for schools. We have 8 schools. Yeah, and DA is very good if you have a relatively small amount of data. Okay, if you don't have a huge data set and you have, I don't know, 100 observations for inputs and outputs, it's better to run DEAs and run a bed regression. Okay? Yeah. So, because you might learn from the DEAs the same, you might want to learn the same information from the DEAs and from the regression. So, what you have here is that you have a cost per pupil, teachers per 100 pupils, outputs for parameters, which is a middle school exam, percentage of students who pass the middle school exam, percentage of students who pass the high school exam, and percentage of students who enter the university. Okay, so both of these, in both cases, you can solve this either with simplex method or interior point method, which is a standard way to solve linear problems. You can solve this with open source solver easily, very quickly actually. So what we get from these results is this kind of a mapping. What I'm getting here is that, okay, S1, S3, and S5 schools are efficient because their efficiency scores at theta is 1, okay? I have these values as well. So just one thing to specify. So from here, if I divide this term over this term, I will get theta. Okay, so my efficient decision-making unit will be one which equals 0, basically. Okay, where this one will give me 1. Yeah, 1. Okay, so yeah, I get that these ones are efficient, and then I'm looking at, okay, these are input parameters. These are output parameters, and these are input parameters, right? So basically, for S4, for example, that has the lowest score, lowest efficiency score, I know that I have to make improvement in, I have too many teachers per 100 pupils, and I know that we have a disproportionately low number of pupils who pass the school exam, okay? Which is why I have a very low efficiency score. So basically, DA can be used well for efficiency assessment. That's an idea. DMUs with if you have a small amount of data, again, you can use DA instead of just running a linear regression. One important limitation is with a DA is that if you have a number of decision-making units which is 3 times less than sum of inputs and outputs, you might have too many decision-making units with perfect efficiency, which is this case actually, because I have 5 units. I should have assessed at least 20 schools or 15 schools, right? And this is why, I mean, these results are not very good because they get too many schools are very efficient, like perfectly efficient, right? And that could be because basically there was not enough data. This could be, DA could be also potentially computationally very heavy if you have a very large number of decision-making units. Let's say 1,000 decision-making units means I have to iteratively solve 1,000 linear programs. Although those linear programs are not very complicated, but still, I have to solve a lot of linear problems. But I mean, with, let's say, if I have 100 decision-making units, I don't know, shops with 100 branches, right? This could be solved even with an open source solver under 1 minute, that kind of a loop. And for those of you who are involved in AI, just don't call it AI if you use it, because it's not AI, it's just simple optimization. Thank you. I have one more slide, which is my favorite translator saying that an important phrase. Okay, questions? Yes.
You talk about that your methods are used for linear model, right? So
Yes.
it's mostly effective. But could you just tell me, do you have such analysis for how significant parameter you use? Our understanding of parameters should have higher correlation with our target value.
It's a very good entry point question. The greatest thing about this kind of analysis is that you don't care about statistics.
Okay.
So you don't have correlations, you don't have variations, you don't have t-tests, f-tests, and all that kind of stuff. You are just ignoring that because you are not. So what you are basically doing is you are only optimizing your relations between your inputs and outputs, nothing else. And that optimization basically gives you a distance or a way to improve your optimal way to improve your inputs or your inputs in order to get to a level of inputs that the most efficient guy has. Okay, that's an idea. So you don't care about all the stuff that you do in statistics. That's not relevant here. Yeah.
Another question. But how, maybe I missed this, but how can we evaluate our model or our method or check our, maybe how our model affects or some real, for example, sales or some business requirements?
Okay. I think this is an answer to that. So I'm here. What I'm saying is not with this model. I'm not saying the stuff that normally a regression analysis does, right? So with a regression analysis, you get a beta coefficient, and beta coefficient tells me that okay, I improve it by beta times, and my output improves by this much. Okay, that's an idea of a very simplistic way of thinking about regression, but can't be done infinitely. I mean, if I increase my parameter infinite times by beta, will that output increase infinite times? Probably not, right? We should keep still in the reasonable stuff. What this one is telling me is that the current reality is such. So there's the most efficient guy, okay? And the rest of the guys have this much difference compared to the most efficient guy, okay? So this is what you can change with the other guys in order to make them as good as the one who is the most efficient, okay? That's and you can do more with that. Okay, so that's probably an idea. So it does give you a functional, it does care about the functional relations between those inputs and outputs, like the regression would care about it, right? Okay.
Sorry, but can we set some constraint for handle, for example, anomaly or some black spot effect, something like this?
Okay, within this model, so there are different kind of, I mean, in more advanced data envelopment analysis, there are models where you can, for example, put certain limits to certain parameters, etc. So probably answer is yes. So you can remodify these constraints so that you put certain limitations on your inputs and outputs, or on your efficiency levels, or on your slacks, for example. Shota.
Yeah. Suppose you have some problem, and this problem is, you show that it's not linear.
Okay, yes.
Its objective function, or the function that you try to optimize, is non-convex.
Yes.
Which solver would you choose, or which package? Commercial, non-commercial?
So it's non-linear and non-convex.
Like the most difficult one.
It depends probably on industry. If that problem is coming from a power industry, let's say, I would probably use Artelis Knitro, this one here, because they have most experience in those kind of problems. Those engineering problems are normally standard ones, so you might want to know guys who have dealt with those engineering problems that are coming in power industry, for example, and they will have the best solver. If you have a non-linear, non-convex, probably Baron is also a famous one. Baron is a good solver as
You
well.
would definitely go with the commercial.
Sorry?
So we always choose commercial.
With a non-linear, non-convex, probably yes. I mean, I will try to do it.
Yeah,
I mean, first I will try to make my problem linear and convex. So, I mean, if I can linearize it, I will try. I mean, let's say you have an objective and constraints, and you just have one nested constraint that has some strange exponential form, let's say, right? So you might not want to spoil your calculations with some non-linear search algorithm that is trying to find an optimal solution from, I don't know, whatever infinity it is searching in, and just try to linearize your exponential function. Okay? So there are piecewise linear transformations for exponential functions. They work well. If you have computing power, you can linearize it so that you have very tiny differences with an actual function, actual exponential functions that you have. So, and then you will solve it with a commercial or non-commercial linear programming solver nicely. Okay. So again, depends on the situation. If you have, I don't know, the problems that is non-linear, non-convex in objective and non-linear, non-convex in constraints, and etc. There might be a case that a specific solver is not designed. I mean, no solver is designed for that, and you have to figure out basically first how to simplify it, relax it, solve a relaxation, like standard. Let's say you do a Lagrangian relaxation, solve a Lagrangian relaxation, and then try to create some kind of a searching algorithm that tries to find an optimal solution for you after you have that relaxation in place.
Okay, but suppose I still stick to some open source source for this kind of problem. How much was the solution in this case? Like, should I expect very liquid divergence,
Okay, that's a good question. There is this project called Viva that is actually doing that, mapping different results from different solvers and giving you that data. So one could, you can Google Viva benchmarking tool for optimization solvers, and it's developed by some student in Finland who had too much time, I guess, and did a really good job with mapping all the solvers based on the results, outputs, and divergences between primal and dual solutions. And yeah, I mean, again, depends on the problem. If you are trying to solve something extremely fast, if you need to solve something extremely fast, then it's better to always use a commercial solver. If you don't care about how fast the solution appears, and you have certain amount of time, let's say, okay, you can use you can use an open source solver easily, and it will give you results as good as commercial solvers. The idea of the commercial solvers is that they are optimized especially for speed of solution. Okay. That's it?
One more question.
Okay.
So, we have a website, as in, can you provide some introductory textbook that's people use to take first steps in this way?
I can. I will suggest several books. I'm not sure whether they are all available online, but several books and some papers probably. Okay. Thank you.
That's good. ვიცი კი და გამორთ. კაი გამახსენეთ, თორე სახლამდე მექნება და ჩაწერე. კი გავაკეთეთ. ან
Can I ask you some advice?
Yeah.
I finally finished my course and now I'm waiting for interview on Monday.
Yeah.
And I'm a little bit nervous, but could you please tell me what tricky question can be from on interview for this data science classic? Yeah. Interview.
Question, I'm telling you why.
Yeah.
I'm interviewed by myself, so I cannot share
okay.
this kind of details.
Okay.
You know?
I see.
Otherwise, it will be I would be happy to answer.
Okay. So it should be some classical.
So my advice, general advice, to review core machine learning material and core data science.
Okay.
Like people sometimes can't answer even basic, how to pre-process data, why to pre-process, how to handle imbalanced data, or whether you should handle it all.
Okay, yeah.
And classical machine learning algorithms.
Yeah.
This is just general, core ML questions that should review.
Okay, thank you.
And be confident. So you have a lot of information. You just need more confidence during the interview. That's very important.
Yeah, I know, but I will try.
Otherwise, I think will be good. I think. I'm sure.
Thank you very much. Thank you very much.
Good luck.
Bye.
ანუ всё, побололи.
ხომარა, თუ
არა, მე მომზადებელი არაფერს არა ვარ.
აი მე და ილიას გაიცანი თუ არა როც. მეგონი ისაუბრეთ, ხო? ჩვენს გაინტერესებდა NLP და LLM-ით, რა? ხო და შეგვიძლია რა თეთრ გავაზიაროთ. შენ ვიცი რომ შემოსავლად მუშაობ.
ეხა ერთ-ერთი რაც შეიძლება გავაკეთო ამ პერიოდში თან ეს რაღაცა ეს საქმეა ცოტა ლაითად ვიყავი ხა ჩემთან და რაღაც ისევ საქმეები დაგროვდა და ვეღარ ვახერხებ ხოლმე. ერთ-ერთი რაც შეიძლება ის რაც ვილაპარაკე მაშინ ეგ მთლიანი პაიპლაინი გავუშვა რა. ოდის ბოლო მომენტებზე ვარ გაჩხერილი და რაღაც ბაგი მაქვს და გამოსასწორებელია და გავუშვებ რა. თუ გამოვა ჩაგვიძლია გავაკეთოთ და პროსტა რა ქვია ანუ მოდელს გამოვდგამ რა შოულებ რა open weight იქნება რა. ანუ data არ ვიცი, იმიტომ რომ data რო გამოვაკეთო მაგინებენ მე მაგინებენ რა სახში მომაგინ. მინიმუმ რა ვიცი საბაგი არა და რა ვიცი მე პალიტა რა ყველანი მომადგებიან ეგ data საიდან. ანუ თელის მაქვს ამოღებული მაგათი. თელი საბას data მაქვს ამოღებული რა.
აი მე ვიცოდი რომ Xpress-ს კონდა ეგ data რაღაც ფორმატს. და როგორ გავცემა საერთოდ?
მე არ გავრცელებულა, ანუ encryption-ს არ ადებენ ტიპები data-ს შეგნით. და რა ქვია, იმაზე რა ქვია, მოკლედ ემულატორზე ჩავწერე მაგათი აპლიკაცია. და შეიძლება დარუხული ემულატორით რა. და იქ ხედავ cache-ში, ხედავ მონაცემებს, ანუ აუდიოები პირდაპირ MP3-ში უყრიეთ ტიპებს და data კიდევ უგდიათ DB ფაილი არის, იქნება ერთი DB ფაილი და იმ DB ფაილში იწერება ის data რა და ყველაზე ცუდი ის არის რომ subscription მოდელი აქვს. და ანუ ჩვეულებრივი ხონდა წყობილი ავტომატური პარსერი, ანუ თვითონ მიდის აპლიკაციაში ამატებს თქვა 4 წიგნს, შეგიძლია ანუ იმ subscription მოდელით 4 წიგნი თაროზე გააჩერო რა. თაროზე ნიშნავს რომ cache-აო. ანუ ის DB ფაილი მომაქვს, სნივა ექსტრაქტებ ვამუშავებ, ვამახსოვრებ, მე იმათ ვაბრუნებ იმ წიგნებს და ეს შემდეგ რა. თან ის საბაკომ.js-ის გავპარსებ მთლიანი საიტი, სადაც წიგნები პირდაპირ მომცოდნა, რომელი იყო გასაპარსი რა. და ანუ პროსტა სიმართლე ყველაზე ხარისხიანი data ჯერჯერობით ანუ ეგ მაქვს და მაგაზე ვუშვებ რა.
რამდენი საქმეა?
ცოტა არის, მაგრამ თვითონ ამ მიდგომის სანახავად მუშაობს თუ არა, საკმარისი იქნება რა. თუ მუშაობს, მე უნდა წავიდეს უკვე scaling-ი რა და მან რავი.
საინტერესოა.
2 კაციც ანუ მოკლედ მან მე ხალხი არა საჭირო რა, ანუ data რო დაასკეილო. მეორე მაქვს ის რა ქვია ეს მთლიანი PDF-ები, რამდენი PDF-ია, არ ვიცი, 10,000 მე შეიძლება მეტი რა. ეს PDF-ებიდან extractions რო ვერ ვაკეთებთ, აი ფონტები ამოვიღეთ, ჩაიმბედებული ფონტები რა. და პროსტა მაგაზე უბრალოდ ჩათვალე YOLO მოდელი დავატრეინერო ეს გლიფების კლასიფიკაცია შეძლოს რა. ბოლოს რაც ქონდა გაკეთებული, ცოტა data ქონდა, გამაზული ქონდა რა, გლიფები, იმიტომ რომ ძალიან ბევრი ფონტია და ხანდახან აი შეიძლება ხოლმე რა. და ეხლა data რაც გვექნება, ეგ ანუ პრობლემა ის არის, რომ ერთადერთი ეშლებოდა ის, რომ მაგალითად, თქვათ, მაგალითად ეშლებოდა 3-იანში და ეგეთები რა.
მაგრამ ფაილები მაინც ეგეთს ცოტა მქონდა.
იცი როგორ თემა არის PDF-ში არის ჩამაგრებული ეგრეთ წოდებული ფონტები. რის მიხედვით ყურეთ, თქვათ, შეიძლება თქვათ ქართული რო წერე, მაგრამ ინგლისური რო წერე და ასე შემდეგ. ამ ანუ PDF-ში შეიძლება ყველა Mac Phones აბსოლუტურად.
მადლობა შენ პირიქით.
მადლობა და მე ხვალ
ბოდიში რომ შეგაწყვეტილეთ შოთა ძალიან დიდ საქმეს აკეთებ ერთადერთ ხელ ერთ სემესტრი data token-ი რო გავაკეთეთ
კი ონლაინ პანდემიის დროს თითქოს რაღაცა ეს 7 თუ ის იყო შეკრება მაგრამ აი დღესაც მახსოვს რომ ძალიან მნიშვნელოვანი იყო ხალხი მოდიოდა თავის პრაქტიკას გაბარდა
ეხლა კიდე აგვისტოი იყო თორე რა პირველზე მაგრამ რამდენი ხალხი იყო სავსე იყო თითქოს
და მე უცად ეს ჩავარდა
ექსპონენციალურად
მოტივაცია მან არ
არა
ერთიც რო იყო
როგორც ფილმს საერთოდ ხალხი გავიცანი ხა მახვა გავიცანი მაგალითად გამოსტილი ადამიანები ის შეიძლება ვერ მენახავდეს ხო
არა ხო დადებითი არის გამოდიორ ხოლმე
ხო და დადებითი უკვე ნახე აუ რა საინტერესოა მე რაც მაგ შეხვედრა რა მექანიკნებით მენეჯერთან მაგ შეხვედრა თორემ ჩემში მაგერთეო სხვა დროს დავწერთ კაი კარგად
ახონდის
ვიგავ
რეალური გავაზე პრობლემა შეხვედრა
მაგ შეხვედრა 10 საათი მან თუანი რა
რამდენი ხანი
ნახევარი საათი
აი ნახევარი საათი დაგელოდე მე დავლიეთ მიდი
დაველოდებით
გაწევთ მე დაგელოდები ანუ არ მეჩქარება
აი აქ ვიდავარ რა ოპერაში თუ არავინ არ არის
ხო ანუ აცებ ხო რამდენი წუთი არის
შეიძლება ვფნაგდეთ ბიჭო რა ვიცი
20 წუთში გეკექნება რა
ხარი რომ ჩქარება
მე არ სტამჩქარება ბავშვი ხო და ვიცი 6 წუთში ერთხელ მაქვს მან თუ არისო თუ რაღაცა მისმაჩი არის ჩემს მაგაშორის რომ დავლაგეთ რა იმიტომ რომ ეხა ბოლო პერიოდში საფრანგეთის დეველოპერები აიყვანეს და რა პროექტს მე ხელმძღვანელობდი ამათთან რა ან ჩატბოტს ვაგეთ ლეგალ ფირმების ხო და ანუ ლიდი უნდა გააკეთოს მაგ ჩატმა რა რაც მე პასუხს იუდულ კითხვებზე შენ მონაცემში შეაგროვოს და უნდა დაგარწმუნოს რომ უთხრა რომ ადვოკატს დამოკავშირდა და მაგაზე ფული გააკეთო და ვიღაცები დაიმატეს ეხა ხო და ისინი რაღაც მეჩრებიან თასკებში და ამჭირდება ხდება მე თან ვაკეთებ და აი მე რები მეშლება მაგაზე რა
აუ ისე მაგას კაკროსის არა კეთებს ექვია ეგენს ლეგალური მასში არ არის ის ტიპიროვარი ექვია იანიკა იან გილჩერი აი ეგეც მაგის კომპანია რო არის მაგას ჩარჩობენ ანუ ლეგალურ იმაში არიან ეგენის როგორც ვიცი
ამათ
იბ ჯაჯ თუ რაღაცა რო ქვია მაგ კომპანიას
ამათ უბრალოდ რა ვიცი თუმცა რო იდროსია რა და 1600-მდე იურიდულ ფირმას გაუკეთეს საიტი WordPress-ში და ჩატბოტი. ანუ უკვე ყავთ ეს ტიპი და ინტეგრაცია ჭირდება იმას. ოპერატორის მაგრამ AI უნდა მიიღო რა API-თან რაც სხვა ინტეგრაციით. და ეგ არის ხოლმე რა თქმა უნდა განსაკუთრებას უცებ შეუძლია რომ არსებობს ეგ. და ეგ თუ ისა დაჭერილი ბაზარი რაღაც გონითა რა იმაში.
ძალიან კარგი. აი მე ვრო გავი ელემს რასაც უყურებ დღეს სიმართლე გითხრა ანუ ძალიან ის არის რა რა ქვია არა ზუსტი იმიტომ რომ ერთი და იგივე რეპეტიციული ტასკი ვაკეთებინო არ გაგარანტია რომ ყოველთვის სტაბილურად შედეგს მოგცემს რა მე რაც დავიჭირე
მაგრამ საქართველოში არიან ტიპები აგერ წინაზე ვიყავით ფაბრიკაში და ეს შეხვედრა რა
არ მე არ დავდივარ ხოლმე მაგეთ შეხვედრებს
მე და ეს ვიყავით და მე ჩვენს მაცინე და რაღაცას გადავავდა იმაზე და მეცნებოდა ბოლოს უყურებოდი ესე და ეს არის ფილიპი აილაბისტები ამბობს რომ ისო რა ქვია OpenAI და Anthropic-მაც არის ცელს ეკეთებინო რა უბრალოდ ჩვენზე მეტი ფული აქვს ჩვენეთო ქართულთან შეგვიძლია ელემენტს კეთებაო და ზუსტად იმდენივე დატაზე მუშაობთ რამზეც Facebook-ი მუშაობს ახლა 500 მილიარდზეა ლაპარაკი 500 მილიარდ ტოკენზე მუშაობთ
ანუ მოიცა რომელი 500 მილიარდ ტოკენზე მუშაობენ ანუ თავისით ანუ თავის პირდაპირ კორპუსი აქვს აღებული და მაგას
არა ჩვენ დამახელდეთ შევკრიბეთ და ქართული ელემენტი დავატრენებთ
აუ აი პროსტა 500 მილიარდ მარტო აზრიდან ქართული ინტერნეტის ვებსაიტი არა შეიძლება დგდეითა მაგ უკვე რაც ათარგმნა
ხო და ვიფუჭეს
ჩოლები მაგრამ მაგ დეიტას შეგვედი გოგემნი ნაგავი არის რა ნახევარი შეგიძლია აი პროსტა ესე გადააქვს ნახევარი და იმას კიდე რო გაცხრევავ ალბათ დარჩება 30% პოლიტი რა რასაც ქვია რა და რავი პლუს ხო ვიცი ანუ ვინც ანუ ხო ვიცი ანუ რა სასტავიც ემუშაობთ და ანუ ქონია ანუ გასაუბრება მაგათთან რა ანუ თვითონ ვინც მუშაობდა მაგაზე აუ არა რა ძალიან შორს არიან ან ტიპები აკეთებენ, აი ჰაგინგ იმაზე რომ ნახავ რა, ჰაგინგ ფეიზზე რო გდია, ის რა ქვია, ბლოგი რო გდია და როგორ დავატრეინოთ მოდელი და copy paste. ეს все მორჩა.
ის კონცეფცია რაღაც ჩატზე. რაღაცებს ტესტავდი დღამე მოვიდა. მეცააზე და რაღაც პირველ საათამდე ტესტავდი. რა ვერ მაიმუნებდი და რაღაცა ის ამდენიმე ის მიწერა და ის ვინ შექმნა შენ რო წერ და იმან მიწერა თვისლი ლაბიშ მე როგორ შექმნა და რაღაცა. მე რამდენჯერ მიწერა იმენ დავუნა რომ დააფაინტუნინგებული ვარ GPT-3-ის ბაზაზეო. GPT-3 დააფაინტუნინგეს სამ დაფუთხო ფაინტუნინგდება ჩვეულებრივ API.
ანუ არ ვიცი მე რაც ვიცი მოკლედ რაც აქვს გაკეთებული მაგათ აქვს ანუ ერთი მოდელი თავის დროს ეს ზღაპრებზე რო გააკეთეს ეგ გააკეთეს რაღაც 100 მილიონიანი მოდელი ან ძალიან პატარა სათამაშო მოდელი დაატრეინინგეს უბრალოდ და ის თარგმნეს რა აუნდ ტიპები რო იძახიან რომ ფი მოდელის ანალოგიო რა ფი მოდელის data ჯერ ერთი არც არსებობს ესე და რაც არის პროსტა აპროქსიმაცია აქვს რა ვიღაც პროსტა სასტავი პროსტა რავი ანუ ვიღაცების მიერ რა პროსტა შეკრული რო აქვს ნუ ნორმალური კორპუსია მაგრამ ანუ ვერ იტყვი რომ ერთ-ერთში ის არის რასაც Microsoft იყენებდა პირობითაც რა აი მაგას თავი რო დაანებო მე ეგ უბრალოდ თარგმნეს ზღაპრები თარგმნეს მეტი კი არ აი როგორი ზღაპრები იცი აი ძალიან მარტივი აი მაგას რავი Google Translate-იც რო თარგმნიდი იდეაში მე და Google Translate-იც ის იგივე შედეგი იქნება. Voilà, ეგ იყო პირველი იტერაცია,